So number one here, I want to solve. I want to get since I have two radicals, I want to get these on opposite sides. So I'm just going to do square root of y squared minus 7y, and I'm going to move the other radical to the other side. So I'm going to add the square root of y plus 9 to both sides. And that gives me this because I had 0 on the right side. So when I add this, I get that by itself on the right side. So I'm going to square both sides. That is going to, wow, terrible parentheses. That's going to get rid of my square roots. So I'm going to square both sides. That's going to give me whatever's under the square root. So just y squared minus 7y equals y plus 9. I'm going to go ahead and get all my like terms together, get everything on the same side. So we'll do y squared, subtract y from both sides, minus 8y, subtract the 9, minus 9 equals 0. I'm going to factor this, two numbers that multiply to negative 9 and add to negative 8. So pause this, take a sec to get those. Let's see, so y minus 9 and y plus 1. Y plus 1. So what might happen is one of these solutions might not work. This equals 0. This gives me two solutions. Positive 9, because if I plug in positive 9 here, this factor will equal 0, and negative 1. Because if I plug in negative 1 for y, this factor will equal 0. So my two solutions are 9 and negative 1. One of them might not work, so we have to test it. Let's test the negative 1 first. So I'm going to try that here. So what I get is negative 1 squared is positive 1. So the square root of 1 minus negative 7, so plus 7. So the square root of 8 minus, and I need an 8 here. The square root of negative 1 plus 9 is 8. So I get square root of 8 minus the square root of 8 equals 0. So that one works because anything minus itself is 0. I like that one. Let's try 9. So if I plug that in, I'm going to get the square root of 81 minus 63 minus the square root of 9 plus 9, which is 18. So this has got to equal 18. And it does. Square root of 18 minus square root of 18, and that equals 0. So I like both those answers. So hopefully they both work for us. Let's check them. Negative 1 and 9, and got it. So let's add 2y to both sides, giving us 5 plus 3y. 5 plus 3y. All right, so I'm going to square both sides here. On the left side, that's just going to give me what's under the square root. So 7y squared plus 15y. And then if I want to square this, I'm doing 5 plus 3y times 5 plus 3y. And I'm able to square the right side because I'm squaring the left side. So I'll square both sides. So on the left side I squared, I got this. And on the right side, when I square, with the y terms, I'll get 9y squared. I will get a plus 15y, and I'll get that twice. So I'm going to end up with a plus 30y, and then a plus 25. The 5s are going to multiply to 25. That is FOIL, first, outside, inside, last, if you are doing that step by step. So let's get all the terms together, set it equal to 0, so we can factor or use the quadratic formula. So I'll subtract the 7y from both sides. So minus 7y squared, sorry, the y squared, minus 7y squared. So that adios on the left side. So I'm working on the right side now, and I have 2y squared. And I'll subtract 15y. Subtract 15y. That gives me nothing on the left. And on the right side, plus 15y plus 25. And I have a big fat 0 on the left here. So this is going to let me factor or use the quadratic formula. So in the hints, it'll show you quadratic formula. But here, I know I need a box because the leading coefficient is not 1. This leading coefficient is 2. So I can't just use simple factoring. So I need two numbers that multiply to 50 and add to 15. Two numbers that multiply to 50 and add to 15. So the top left, regardless, I'm going to put my leading term, and the bottom right, I'm going to put my constant term from the original quadratic. So the 2y squared in the top left, the 25 in the bottom right, and my two numbers are 10 and 5. Those will multiply to 50 and add to 15. So I'll do 10y here, 5y here. So going across the top here, I'm going to pull out the greatest common factor. This is box method. So the greatest common factor between 2y squared and 10y is 2y. Greatest common factor between 5y and 25 is 5. And I'm going to add these two. Everything's positive. I can pull out only y from here. And then here I can pull out 5. So plus 5. So I'm going to factor this as 2y plus 5 times y plus 5. All right, and that's all equal to 0. I already have 0 there. Nice. So if this is equal to 0, I am going to set each factor equal to 0. So this one is easy. -5 is what you're going to get when you set it equal to 0. With this one, 2y plus 5, set that equal to 0. So you're going to get 2y equals -5. Divide both sides by 2. Y is -5 over 2. And so we have two answers here, -5 and -5 over 2. One of the main reasons these questions are so tricky is now we have to check both of these because we're taking square roots and we're squaring things. And when that happens, sometimes you get what are called extraneous solutions that when you plug them back into the original equation, just don't work. So let's check both of these for that, that case. So if y squared would be positive 25 times 7 is 175. The math here is not nothing. It's kind of tricky. Plus 15 times -5, so that's minus 75. That's nice because we're going to get the square root of 100, which is 10. Minus 2y, so that's minus -10, which is plus 10. And then on the right side, we get 5 plus y, which is actually going to be 0. So this is going to say, if I simplify this, this is the square root of 100, which is 10. And then minus -10 is plus 10. So it's saying 10 plus 10 is 0. I do like this as an extraneous solution, meaning when we plug it back in, we get something like 20 equals 0, and you can keep moving stuff left and right, but it's not going to work. So I'm going to say -5 is not a solution. -5 over 2 times -5 over 2, that's going to give us positive, and I'll multiply the top and bottom. So -5 over 2, I'm just a ton of stuff here. I'm sorry about that. -5 over 2. So if I multiply these, they're going to be positive, and I'm going to get 25 over 4. So that's y squared, and it's multiplied by 7. So that's 175 over 4, and that is ugly, but it is what it is. 175 over 4 plus 15 times -5 over 2. So that's going to be -75 over 2, right? Yes, -75 over 2. All right, yeah, I believe that's right. Okay, and then minus, so we're going to need to get those denominators the same. Minus 2y, so that would be minus a minus is going to give us plus. And then 2 times this is 10 over 2. And this equals 5 plus y, which I won't even write the 5. 5 plus this, I'm going to rewrite 5 as 10 over 2, and then it's plus -5 over 2. And this is messy, 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 messy. On the left side here, I have the square root of, so I'm going to rewrite up here, the square root of, it's 175 over 4 minus 150 over 4. Because I need to get this denominator to 4, I need to double the top and bottom. Plus 10 over 2 equals, this is 5 over 2. All right, so square root of this is the square root of 25 over 4. Square root of 25 over 4 is 5 over 2. The square root of 25 over the square root of 4, because you can do the square root of this over square root of 25 over square root of 4. So we'll get 5 over 2 plus 10 over 2 equals 5 over 2. And to me, that doesn't look right either, because we're getting 15 over 2 equals 5 over 2. So this is one of those where they're really getting us. And it looks like there's no solution here. So hopefully we get this. And we do. Yeah, so you do have to check both. It's not fun. All right, so I did have to go ahead and solve this one out before just to make sure I could get through all the writing and things like that. So in these first two steps, step 1, I just got the radical by itself, subtracted 2 from both sides, and rewrote the right side as -2w plus 5 instead of 5 minus 2w. Then I'm going to square both sides here. So that's what I did. And that takes me to my second step. So when you multiply negative 2w plus 5 by itself, again, you have to FOIL that. And that's what you end up with. So now I'm going to just combine like terms. Subtract 2w from both sides. So on the right side, I end up with 2w squared. I'll add the 19w to both sides. And so now that's actually going to give me minus w. And then subtract 31 both sides, I actually get minus 6. And then 0 on the other side. So from here, I'm going to factor. I need two numbers that multiply to negative 12 and add to negative 1. So they do multiply to negative 12 because that's negative 6 times 2. So multiply to negative 12, add to negative 1. Those numbers are negative 4 and 3. So I'm going to set up my box method. So in the top left goes the leading term, 2w squared. Bottom right goes the constant. This is always true. Now what I'm going to do is put the negative 4 up in here with the w. Doesn't matter which one goes where. 3w. Across the first row here, I get 2w is my greatest common factor. Across here, greatest common factor is 3. I will add those. Everything's positive. Down here, greatest common factor w, greatest common factor negative 2. So I end up with 2w minus 3, sorry, plus 3 times w minus 2. And that equals 0. So I factored this, and that's going to help me see that the two solutions are positive 2, because w minus 2, to set that equal to 0, w needs to equal 2. And here, I'm going to get negative 3 over 2 if I set that equal to 0. So we are going to test these. I'm just going to tell you the two works. The negative 3 over 2, I want to show you because it is really tricky. I honestly think it is a little unnecessarily difficult, but let's test the solution negative 3 over 2 and confirm that it works. I will clear the drawings. Square root, so w squared, so that's negative 3 over 2 squared, so times itself, that's going to be positive, I don't know why I wrote it like that, so positive 9 over 4. Multiply top, multiply bottom, ends up positive 9 over 4, times 2 is 18 over 4, it's times 2 over 1, minus 19 times this, so it's going to be negative 57 over 2. Negative 57 over 2. That is 19 times negative 3 over 2. Again, unnecessarily hard. And then put 31 over 4, and that's going to give you 124 over 4. All right, so let's just deal with this square root thing first. This is going to give us square root. I want everything with a 4 on the bottom, so I'm going to get 18 over 4 plus, because I get minus the negative. Double this, it's going to be 114 over 4 plus 124 over 4. What you end up with is the square root of 256 over 4. And that works out brilliantly because I'll take the square root of top and bottom, and I get 16 over 2, which is 8. So I can write that as 8. So all of this whole mess turned out to be 8. So I have 8. Yeah, seems right to me. I hope that's all right. 8 plus 2 equals 7 minus 2w, and w being negative 3 over 2. So that gives us 8 plus 2 equals 7 plus 6 over 2. And that's going to give us 10 on the left. 10 equals 6 over 2 is 3. 10 equals 10. So both of the solutions work. Our solutions were positive 2 and negative 3 over 2, which as a written like decimal is negative 1.5, or with decimals is negative 1.5. All right.